Greetings. I'm going to give you an introduction to the AFW optical printer. So for this trick you will need an AFW optical printer and a Bolex. So we're going to mount the Bolex obviously here. Now let's start with the general setup of the thing. There's one cable that needs to be plugged in, so plug it in. It connects to a power board with a switch. There is a switch on the power board. Switch it on. Right. Now, all things being equal, both screens will illuminate for the control box and for the light box, the LED box, right? There's two controllers. The LED one is powered by its own 12-volt plug pack here, and also by this blue cable that connects it to the control box. Okay, this blue USB cable is important. The lamp is powered by the 12 volts, but the Arduino that powers the LED is from the blue USB cable, so that has to be plugged in. Also, there's separate power now for the internal Arduino on this thing, which is one of these plug packs as well. So it used to all be powered from just the one cable, but now there are these two plug packs. Okay. So the on-off switch only affects the on-off switch only affects the motors and the lamp here. It doesn't affect the internal Arduino. So if you turn this off, the internal Arduino stays on, which is a good thing, or a bad thing, depending on which way you look at it. Okay, so now one thing I want to just point out. See these connectors here? They connect the control box to the camera. It is essential that they be plugged in 1, 2, 3. See the numbers 1, 2, 3, 1, 2, 3. You shouldn't need to unplug these, but if someone has unplugged them, please check that 3 is with 3, 2 is with 2, and 1 is with 1. Failing to do that would be really problematic. Okay, so that's the most important thing about setting up. So right, so the first thing you're going to need to do is mount the Bolex. This is the camera mount, which is just like a tripod mount, but it's been mounted onto this lead screw of the slidey uppy downy thing, and it has a camera plate. So you can, once this is mounted to the camera, you don't need to unscrew this again. Use the bottom camera tripod thread there, and this plate. See this line here? You're going to line it up such that the screw is lined up with that line. Okay, so I'll just put this on and then line it up. It's about 50% there through the line. Okay, tight. There we go. Tight probably matters, because with optical printing, once you've got things set up, you don't want to bump them. Then it's a matter of sliding this in. Now, once you go beyond a certain point, it's locked in. To release it, you would press this button. But to lock it in actual position, on this side, there is a rotating clamp, or thread thingy, right? So, obviously, we can choose where we want to put it. Line the end of this plate up with the end of this part of the bracket of the camera mount. So, and that should put, I'll lock it in there, that should put the lens position in the center of the lead screw, right, which is the center of our optical printer lens. Okay, we are going to use we're going to use this lens rather than a normal camera lens, because that's how an optical printer works. The lens is a separate thing that can be moved forwards and backwards. In order to shield the camera from excessive light coming in on an angle, we use this, what do they call those? Extension tube. The extension tube is working effectively just as a shade, so that no extraneous light is going to get to the prism or anything like that. So we do have to mount the single frame motor that goes here so that the camera's motor can be driven by the control box. First thing you have to do is take off the normal winder. leave it here on the bench so it doesn't get lost. Okay, the next thing you've got to do is you've got to turn the spring motor off. So that's what this lever does. You will have seen that somewhere. And then you have to turn this, you have to lock the trigger. This is important. Lock the trigger. This is the same whenever you put any motor on a Bolex. It also makes sense to put the speed up to maximum speed, 64 frames a second, because that makes less work for this motor to do. It just so happens that the speed governor inside the Bolex is still active even when you're using an external motor, and so the external motor is fighting the speed governor, and that makes for more wear and tear of the mechanism. So put it on the easiest one to move, which is 64 frames a second. Okay, so this simply screws on, if you get it around the right way. Obviously this shaft here will go into the single frame, this one here, the single frame drive shaft of the camera. And then once that's in, all of these little screws I think there's only the 3 of them, 2 at the top, 1 at the bottom. Alright, that's done. Now let's just have a look and see if there are any controls on here that we need to worry about. This switch that has long exposure normal should be on normal.
Is it?
Yep, there. Long exposure normal, it should be on normal.
Mm-hmm.
Now, we do have the capacity to use this knob here to go forwards or backwards, rewind forwards. So if, for instance, so we would leave it on the normal position, right? We leave it in the normal position, but if we wanted to, if we've done some exposures, or if we're still loading the film, we forgot to load the film before we took the spring motor off, you can just turn that motor on and it will just slowly turn over the film. So that's turned it on in the forward direction. Or, for instance, if we've just done 100 exposures and we want to rewind the camera, we can do it this way. This way, rewinding, looking at the frame counter, the frame counter as we do it. Looking at the frame counter as we rewind. You see that going upwards. And then you stop it where you want it. Of course, like any rewinding situation with a Bolex, you would shut the variable shutter. If you were rewinding, here's the variable shutter. You would shut that. If you didn't shut it, you'd be multiply exposing the film. Yep. Alright, so now we're up to loading the projector part of the optical printer. Now, this is actually an old animation camera, not a projector, but we're using it as a projector because it has a hole here, and we've put a light. This light will be able to come in and illuminate the scene, so it'll work as a projector just as well as a camera. Like a camera or a projector, it has an intermittent motion. It'll move the film a frame at a time, and it involves loops. So we'll have loops up here and down here. Alright, now optical printers are funny in that you want the image in the viewfinder, you want the image in the camera to be the right way up, naturally enough. Film in a projector is normally goes through head first. So when you would normally expect to put the supply film here and have it go through the mechanism and then back out to the take up here. But that would be putting the image in the gate area upside down, right? Like the little man would be standing on his head, just like he was going through a film projector. So what we need to do is have the little man in the gate the right way up, which means threading from the bottom up. So counterintuitively, on all optical printers, the supply of film goes on the bottom and it's taken up at the top. That's just how optical printers work. So you'd have some leader on the front of your image so that you don't damage your good bit of film. And then you need to clamp it onto the sprocket wheel, just like on any projector or camera. make a loop. I wonder if it would help if I turn this little light on. That probably helps. Make a loop manually. Now, with my fingers, I'm forcing the film into the film channel there. And then I'm going to end up similarly clamping the film under the top sprocket wheel. Once I've done this, you'll be able to have a better look. Okay, now that top loop's a bit big, but it honestly doesn't matter. So there it is, that's the thing. Now, we have to, that's the two loops here, and the sprocket wheel, and the take-up will be up the top here. Now we have to put in the other part of the gate, which is this pressure plate. This pressure plate is removable, so please don't lose it. Now, you'll notice it has several pins. Only one pin is, let's say, recessed, and it goes into this. I'll point with something. I'll point with these scissors. This, can you see this? This pin here is going to go into this notch here. So let's do that. There we are. That is that pin in that notch. That stays there more or less by itself, but you will need to put these springy clamps. See the other ones here? To actually hold it in firmly. So see these springy clamps? Are they clear in the picture, Carl?
Yep.
All right. So yeah, they just hold it in. Okay. Now the camera is the projector is correctly loaded. However, we have made a little diffuser that diffuses our LED light to be a nice even light, and that wants to go in at the back of the pressure plate here. And it just, once it's in the right spot, it should just hold itself in place. Okay, right, so there's the diffuser. A little bit tricky to load, but there you are. Now, this is the lamp. The lamp is on a 3D printed plastic bracket, and we're going to be able to rotate it right into the position there. Now, the thing about this is don't be tempted to pull it from the here. Please always rotate it from this big knob so as not to break it. Okay. Let's have a look at the light box, the light controller for the RGB LED for the optical printer. When you turn it on, it will look like this. This is the first mode that comes up with the on the thing. Now, this is a way of programming a particular set of red, green and blue values, but they're not activated until you press the red button, which is here. Press the red button, and now that light is the light that's depicted here. 1935-31 is the number for that coloured light there. However, for using it as an optical printer, you'd probably find it more useful to use the second mode. The second mode is entered merely by holding this button down until the screen says MMM. Like this did, and there it is, manual control. And in manual control, there's none of this button pushing, it's just a matter of dialing up the set of numbers you want. And certainly in order to find a colour combination that you're interested in, this is probably the more direct way to do it. Once you've got the colour combination, you could reset, let's say your colour combination was 18, 23, 35, you could reset it and type that into the first mode, and then press the enter button, and it'll be 18, 18, 35 or whatever it was, whatever, I forget what we said, right, and it's there now, and it can't be bumped. It can't be bumped. These numbers change, but the top row of numbers, which is what the lamp is actually doing, don't change. That's not a bad thing. The other thing that's an advantage about that is you don't want to leave, this is important, you don't want to leave this LED on just indefinitely. You want to turn it on and off. And the way to do that is to press the black reset button, right? Hit the black reset button, and now the light is off, right? But if I've still got dialed up on my red, green and blue knobs the value that I want, and I know that what that is, perhaps I've written it down, then to turn it back on I merely have to press the red button, and now I have that same light again. And then to turn it off I hit the black button and it's gone, and then when I want it again I can just turn it on. So that's how I'd like you to use it, turning it on and off. Okay, that is enough, except for the question of how do you know what color combination you want. Well, you either want colors for color's sake, or you want, say, daylight because you've got daylight film in the Bolex, or you want tungsten because you've got tungsten film in the Bolex. And the way you should determine the color balance is either through painful testing, or get a color temperature app for your phone, and then you can just hold it in front here without film in the gate, of course. Hold it in front and dial it up until it says 5600 degrees Kelvin for daylight, or 3200 degrees Kelvin for the tungsten, and away you go. And that's a really powerful development with optical printing, being able to use a color temperature app very easily. Okay, so the next thing we want to talk about is the rails that the camera and the lens are on. Camera, lens. The camera's on one rail and the lens is on another. We just did it that way. They didn't have to be so you can see the lens is projecting forward. Now it's a little bit wobbly, but it's fine if you don't touch it while you're filming. Now, see this mark here? That is let's call it the 1-to-1 mark. When the camera is there and the lens is on this mark, right, you are in focus, and that is what we call a 1-to-1, as is it's the same size image, right? So it's more or less you're copying exactly what's on the film. Now here's the interesting thing. The camera never needs to be closer than this mark to the projector, right? If you don't want 1-to-1, it's because you either want to enlarge or reduce the image. Both enlarging and reducing are in this direction. Hello. Hello. Are in this direction. So for any one camera position back here, there are two lens positions that are useful. One will be for reducing and one will be for enlarging. Now, almost always what you'll be doing is enlarging. Reducing is an unusual application, but you might want to do it. Reducing means, you've got a 16mm sized image here and you want to make it smaller than the actual picture area on the Bolex. So you're actually making the image with a black background. Anyway, so as I say, for any one position here, on the camera axis, from here back, there are two lens positions, and one will be enlarging and one will be reducing. From memory, when the lens is closer than this red line, it will be enlarging, and when the lens is further away than this red line, it will be reducing. Okay, the next thing we want to point out is the other ways of moving the lens position. You'll notice that there's this vertical, what do you call this, lead screw here, and there's another horizontal lead screw here. These two control the whatever it is, the Y and the X axis of the lens, right? So rotating this lifts the lens up or down, and rotating this moves the lens left or right. Now, the thing is, this determines where your picture is in the viewfinder. So if you were trying to enlarge, just say, someone's face from a picture, you'll need to be able to, move the image until you've got just the face in the viewfinder of your Bolex. So that's what they're about. So right now, I'm going to just show you this thing about two lens positions for any one camera position. So I'm going to move the camera to an arbitrary spot along here. Hello. And then I'm going to, Carl will put the camera through the viewfinder, and we'll adjust this lens position forwards and backwards, and we'll see, hopefully, that there are two positions that make it work. So, right, okay, well it's hard to see, but that is the image in focus, just putting the camera through the lens, and the image, the film image, the 16mm film image in the projector is smaller, so it's just a little square inside the viewfinder. And now we'll bring the lens forward, further forward from that red mark on using the lead screw. So put the, I'll be turning like this.
Just have a look at that first.
Yep, turning like this on the lead screw. And it makes the lens go further forward. Okay, and then, yep, let's see what we've got. So it'll take a moment to find it. Looks like it's coming. Yeah, right. So for any, and so that's an enlargement. So the point is, for any camera position, there are two lens positions. Okay, let's have a look at the control box and some of the basic controls. There are two ways to operate the camera and projector. They have the camera's got a motor, which we just attach, and the projector's got a motor, which is internal. There's two ways to operate it. We can either operate it just by pushing these buttons, which operates the projector or the camera, or we can have the computer, the Arduino inside, do the operation of the camera and projector. So let's start with the manual control, where you do it instead of the Arduino. Okay. Here we have a switch called direction control, auto manual. Well, naturally enough, if we want to control the direction ourselves manually, then we have to have it in the manual position. And if we want the Arduino to control the direction, we'd have it in auto. So let's have it in manual. Then we've got the projector, forward or reverse, and the camera, forward or reverse. Typically the camera will be forward, because as you know, if we go backwards in a Bolex, the claw will be pushing here as opposed to pulling here, and this will, in terms of the sprocket, the perforation, and this will result in a different framing of the image. So you really can't take pictures backwards in a Bolex. So you normally would be on forward, and you'd just be on backwards when you want to go back a few frames in order to go forward again later for another exposure. So let's leave it on forward. Then it's simply a matter of pedaling. You can press this button and the camera moves a frame, press this button and the projector moves a frame. You can move the projector backwards if that's what you want to do. So let's say you wanted to do some sequence where you went 2 camera frames for every projector frame, and you want the projector in reverse. So you put the projector in reverse, you take 2 camera frames, then move the projector back 1 frame, then do 2 more camera frames, projector back 1 frame, 2 more camera frames, projector back 1 frame until you're happy. That I call pedaling, even though it's using your fingers. Alright, that's manual control. But let's look at the auto control. So now I'll switch to the auto direction control position, in which instance we're going to be interested in this screen. Now there's only 3 buttons that are relevant. Once it's in the auto direction mode, only these 3 buttons are relevant. Everything is controlled by them. This is the enter button, and this is to make numbers go up or down, up or down. So let's have a look. Let's try and do a little program. Let's do a simple program. Let's do a simple 1-to-1 program. Okay, you can see the projector. Currently it says proj 01. That means it's 1 frame. I can change that to 2, 3, 4, 5. Let's just do 1-to-1. So I'll go projector 1, enter. Now camera's saying 0, so let's make it 1 frame. So now it's projector 1, camera 1, enter. Right. How many times do I want it to do that? Let's say I just want 15 frames, which is not very much. I can just keep holding that down until it says 15. Enter. So now it's going to do a 1-to-1 print, as in 1 projector for 1 camera frame, 1 projector, 1 camera frame, 15 times. Okay, now it's asking me, it's saying I'm about to print, I'm programmed ready to print, press the enter button again and it will print. So you can hear the camera's moving, then the projector's moving. Naturally, the camera always moves first. All right. What about if you wanted the projector to go backwards? Well, that's easy. Instead of having positive numbers there, you have negative numbers. So let's say we wanted to do what we call skip printing, where we skip every second frame. For every camera, we move the projector 2 frames. So let's move 2 frames backwards. So for every camera, we'll move 2 frames of the projector backwards. So I've got it on -2. Enter. And then the camera will still go forward 1 frame at a time. Enter. So how many cycles? Let's do 10 cycles of that. Right. Print. So you can hear it's doing 2 cameras. Sorry, 2 projectors, I should say. 2 projector frames for every 1 camera frame. It's also worth noting that it's moving backwards in the projector now because it was a minus number. So that's how that works. Now, the last thing I want to show you on the programming front is how to stop it if it's gone crazy. Let's say you've typed in 3 for projector and you want to type in 2 for camera. And now you think, oh, I should have made it 4 for camera. Well, if you hold this button down, it stops and allows you to do it again. So now we're at 3 for projector, and I can change the camera to 4. Right? So just holding the enter button there sort of cleared the mechanism. So we'll do another 10 cycles of that, so enter that. Printing. Now. Well, the light isn't on there, Carl. I'll just turn the light on so you can see. Now, back over here, Carl. Let's say I say, well, that's enough. I can stop the process just by holding down the big enter button and it'll just stop dead. Right. Okay. Another thing it's worth knowing are these counters. See how it's saying it's got 2 columns. It's got a blue column and a green column. The blue column being for the projector, the green for the camera. And it's showing you what it just did then. It did 17 projector for 24 camera, which is about right since we had it on 3, 4. The 17 projector, 24 camera. It's also showing you where the projector and camera are globally. That is, if you started it will have started at 0. At the moment, it's on 12. Remember, we did all those backwards frames, so that would have gone in the negative numbers and then gone forward again. So these can be useful. You also have the frame counter on the Bolex. That's a very useful thing too. But otherwise, you've got these counters here, these digital counters that are worth bearing in mind. If you want to reset them, the only way to do it is to press the reset button, and that resets the whole Arduino. And it'll reboot, and there it is, back, and they're all at zeros.